the US mainland per year was about 0.6. Now, giving that mean value, is that a clue about anything? We didn't use the mean value in the binomial one, right? We had to calculate it, and we could, like n times p, right? But notice, if you look at the formulas, the formula on page 223, that funny Greek letter mu, right, that is the mean value. They give you that. So them giving you the mean in these problems, that's kind of a tip-off that you're using Poisson. Anyway, or it's either extraneous information and trying to trick you. The mean number of major hurricanes to strike the U.S. was 0.6. Find the probability that in a given year, exactly one hurricane will strike the mainland. Then at most one hurricane, and then more than one. All right, so Poisson distribution.
Oops.
All right, so for Poisson, we need the mean, which is actually that Greek letter mu, and we need to know x, the number of trials, successes. So what is the mean? 0.6, right? And the probability that a certain number strikes is, say, for instance, in part A, x is equal to 1 major hurricane. So this is how many of the successes you have. Here, success is a hurricane hitting the mainland. Success isn't always what you think it is. So.
Yeah, see that.
That's success from the point of view of the hurricane.
Mm-hmm.
All right, so the actual probability, we can calculate using this function. So the probability that x hurricanes strike would be Poisson. And notice you only need x, the mean, and then this cumulative thing. I'm betting the cumulative is the same as it was before, where it's true or false, and they follow the same idea. But we'll look it up real quick. So x is that, comma mean is that. You can type the numbers in, you know. You could just do Poisson 1, comma 0.6. So I'm using that, so if I change the numbers, it's like a workable calculator. So I can use this for any other problem. So you can use this thing, and you can go back, and if you guys have another problem on a quiz or a test, you can just change these numbers, and this stuff will automatically change. If you want to use it that way. All right, so let me check this out. Cumulative. So
yeah.
If it's true, it's a probability that the number of random events occurring will be between 0 and x inclusive.
False. Okay.
If false, it's the number of events will be exactly x. So we want false. False means it's exactly that many hurricanes. True means it would be 0 hurricanes up to that many. Mm-hmm. It's kind of like an at most idea. So we want false again. And that would be probability
Wait a minute now.
of x successes. That's actually a probability of getting one hurricane hit the main. It's a pretty good chance. Right? Seems like you're giving it so little information, and it's just giving it to you. Anybody get that feeling? All you said was the mean value, and you want to know how many. Really, all you gave it was 0.6. And you say, what's the chance of getting 1? Just based on this, that it averages 0.6 a year, it knows that it's that. Just doesn't seem like it's getting much information, and somehow pulling that information out. There's got to be some assumptions going on here.